Y'all, today we're going to be talking about writing equations of lines. So when we write an equation of a line, remember from our slope that we just did, our equation of a line in what we call slope-intercept form is y equals mx plus b. Okay. Now y equals mx plus b, just a recap of what all of these variables mean. So y and x are just y and x, our variable y and our variable x. Okay, x and y on the graph, same as they've always been. M is still what we call our slope. And B, if you remember, is our y-intercept. Like so. Okay. Now we might also be asked about parallel slope or perpendicular slope. So remember, parallel slope is the same. Perpendicular slope is the opposite reciprocal. So just kind of going into those. So the same is the same. So if my original slope, so if m is equal to 2, my parallel slope would also be equal to 2 because parallel lines are two lines with the same slope. Okay, perpendicular slope, that opposite reciprocal. So same idea, if my slope is 2, then my perpendicular slope, I take the opposite, so it changes from a positive number to a negative number. If it was negative, it would change from a negative to a positive. And then I take the reciprocal. So 2 over 1 becomes 1 over 2. I just switch the numerator and denominator of that fraction. Okay, so let's actually write some equations. Okay. So the simplest one you could get is if I just straight up give you slope and y-intercept. So let's write our equation. I'm giving you m is equal to negative 2 and b is equal to 5. So we just plug both of those straight into the equation. So y equals negative 2x plus 5. Pretty straightforward. Okay? Kind of moving up the ladder of difficulty. The next one is given a point and the y-intercept. So remember, there's two things I need for my linear equations. I need slope, and I need the y-intercept. So right now, I already have the y-intercept. I already have 0, 5. So the only thing I need to do is I need to find slope. So to find slope, I just take my 2 points, so 2, negative 3, and 0, 5, line them up. So to get from 2 to 0, that would be negative 2. To get from negative 3 to 5, that would be positive 8. So I have 8 divided by negative 2, which would be equal to negative 4. Okay, so I have my slope, that's my m. I have my y-intercept, which is just the 5. Okay, so then I just plug both into my equation. So negative 4x plus 5. Hey, moving up in difficulty a bit. Okay, what if I give you the slope and I give you a point to work with? Okay, so given slope and a point. So right now I have the slope negative 4 over 5. So can I go ahead and plug that into my equation? Absolutely. So my slope would be negative 4 over 5 x. Okay, then I don't know my y-intercept. Okay, so this is a little bit different. This is something we haven't done before. So when solving for a y-intercept or solving for a point, I can plug in an x and y value into my equation because really right now, what I have with this information that's written is I have y is equal to negative 4 over 5 x plus b. Okay. Now, x and y are always going to be x and y. I want to have them in my final equation, but I don't know b. I don't know my y-intercept. So to solve for an unknown, I need to plug in for all of the other unknowns in the equation, so I only have one variable that I need to solve for. So I want to solve for b, so I need to plug in for x and y. Well, I have a point, and as we know, all points are x, y. So I have an x and y value that I can plug in for and then solve for b. So I can now replace y with the y value, which is 1. and replace x with the x value, which is -5, and plus b. Okay, so then from here, I'm just going to kind of do some work to simplify. Now, the first thing you notice is I have that -4/5 times -5, so I got to simplify that. All right, if you struggle with this a bit, you can always type that in your calculator, okay? But remember that this -5 is the same thing as -5 over 1, okay? It's a whole number, so it's always over 1, okay? So we have two fractions being multiplied. So if I wanted to multiply the fractions across, okay, that would give me positive 20 over 5, which 5 goes into 20 4 times, okay? What I can also notice is that 5 and -5 are in that opposite position in the fraction, okay? If I have two numbers in opposite positions in the fraction, I can reduce them by a number they're equally divisible by. 5 and 5 are both divisible by 5, so I can also reduce this to -4 over 1 times -1 over 1, which would just equal -4 times -1, which would be 4. Okay, so either way is a good way to reduce that fraction, or you can always just type it into the calculator if you forget those. So we now have 1 is equal to 4 plus b. So if you notice, the hardest part really is just simplifying that slope times the x value. Okay, so now from here, I want to solve for b. So subtract 4 from both sides, -4 minus 4. 1 minus 4 is equal to -3. So for our b value, and I know it says plus, but realistically, we don't want to write plus minus. We just want to write minus. So minus 3. Okay, and that's our equation. Okay, so a little bit more difficult because we had to solve for something. We didn't just kind of have everything given to us. Okay, last but not least, we want to write our y-intercept equation given 2 points. So this one, I'm not given an intercept, I'm not given slope, I'm just given 2 points. So I have to find both things. So the first thing that you always want to find is you want to find slope. So I find my slope by lining up my two lines. So -5, or lining up my 2 points, sorry. So -5, comma -2, over 5, comma 2. Change in the x direction, getting from -5 to +5 would be 10. Change in the y direction, getting from -2 to 2 would be 4. So m is equal to rise over run, or change in y over change in x, so 4 over 10, which would be equal to 2/5 if I reduce it. Okay, so now I can plug that into the equation I have so far. So this would be y is equal to 2 over 5 x plus b. Okay, so now, just like last time, I want to solve for b, so I'm going to be plugging in one of my x comma y points. Now you have a choice. You can plug in either of these 2 points. Any point that's on the line will technically work and solve for b. Now between the two, do you think you'd rather work with negative numbers or rather work with positive numbers? I personally would always rather work with positive numbers, so I'm going to pick the point 5 comma 2. But it's up to you. Both points work. So 5 is going to go in for x. 2 is going to go in for y because it's always an x comma y point. So 2 is equal to 2/5 times 5 plus b. I'm going to just kind of jump ahead since I showed you the shortcut last time. Since 5 and 5 are in opposite parts of the fraction, I can cancel them out, which means I'm left with just 2. So 2 is equal to 2 plus b. Then I can subtract 2 to get b by itself. So we actually get 0 is equal to b. Okay? So if we get a b value of 0, then that means our y-intercept is the origin. It's going straight through the middle of the graph. So we can write it as 2/5 x plus 0, but if I'm adding 0, do I really even need to write it? No, so we can also just write this as y equals 2/5 x. Okay, nice and straightforward like that. Okay, so those are kind of writing from various different points, different values given to you. Okay, the last two things we're going to talk about is graphs and word problems. So writing a linear equation from a graph, it's actually kind of like I've given you slope and the y-intercept because they're both there on our graph. So we're just going to pull those two things out, slope and the y-intercept, and we're going to use them to write our equation. So our y-intercept is going to be where it crosses the y-axis on the graph. So looking at number 5, we cross the y-axis right here at 3. So b would be equal to 3. Okay, our slope, we just pick 2 points. Okay, and you always want to pick points where it goes through those nice grid lines so they're easy to count. And I do my rise over run. So rise of 1, run of 1. So slope would be equal to a rise of +1 over a run of +1, which is just 1. So for my equation, y is equal to 1x plus 3, or just y is equal to x plus 3. Either one is fine. Okay, let's do another one. So on 6, y-intercept first. So our y-intercept is right here. We're going through -1, so b is equal to -1. Okay, pick 2 points where it goes through the points. So let's see, right here at -4, 1, and really the next one it looks like is our y-intercept. Or of course you can always go all the way down here. You can go a little further. That's fine too. Okay, so my rise is down by 2. Remember, we always move left to right. So down by 2. And then 1, 2, 3, 4, 5. So a run of 5. So my slope would be equal to -2 over +5. And that doesn't reduce. 5 doesn't go into 2. So we can just leave it like that. So y is equal to -2 over 5, x, and then -1. All right, last but not least, number 7. Okay, our y-intercept, where does it look like it goes through the graph? Well, it's pretty kind of close here, but it does look like it goes through right here at -2. Okay, so after we do that, b is equal to -2. Then I need to do my slope, so I need to pick 2 points. So let's see. These points can be a little hard, but definitely looks like right here at 1, 4, I got a point. And of course, right here at the y-intercept is always a point. So you can always use your y-intercept as one of your points, just something to remember. I move left to right, so I'm going to do my rise first. So I'm going up by 1, 2, 3, 4, 5, 6, and then my run of 1. So our slope would be +6 for our rise over +1 for our run, which is just 6. So plugging into our y equals mx plus b, y is equal to 6x minus 2. So I kind of like pulling them from graphs. They're pretty easy. It's like the values are just there. I don't have to do any real complicated math, okay, except, reducing slope if it reduces nicely. Okay. Last but not least, last thing we're going to talk about today is writing linear equations from word problems. Some of these are really straightforward. Some of them are a little bit more difficult. You just kind of have to read by the situation. Okay. The table below represents the relationship between the cost of buying gasoline C and the number of gallons G purchased. Write the equation that best describes the relationship. Okay, so if I buy 5 gallons, it costs $7.10. If I buy 10 gallons, it costs $14.20. If I buy 15 gallons, it costs $21.30, and so on and so forth. Okay, so one thing you might notice, and we don't have that point, okay, but if I went all the way, what's the difference, I guess? So let's find our slope. Let's find what that slope value would be. And remember, finding slope or finding rate of change from a table, we just look at the change in our x value versus our change in our y value. So in this case, it would be G and C. So our change here would be plus 5. 10 to 15 would be plus 5. 7, 10 to 14, 20, that would be plus $7.10. 14, 20, 21, 30, also plus $7.10. And you can always type that in the calculator if that math's a little hard. Okay, so we're having a constant rate of $7.10. Okay, so if I was to calculate my slope, m would be equal to 710 divided by 5. Okay, and the reason why I'm putting the 710 on top is because the cost of buying gasoline is dependent upon the number of gallons purchased. So G is my independent variable and C is my dependent. So G in this case is acting like our X and C is acting like our Y. Okay, so real quick, let's type this in the calculator. 710 divided by 5. All right, and we type that in the calculator, we get $1.42. So M is equal to 1.42, okay, which means each gallon is costing $1.42. Now, something you might notice, okay, is if I go all the way to 0, I would take away that $7.10. So how much does it cost to buy 0 gallons of gasoline? It doesn't cost anything. So what do we not have? Okay, we do not have a y-intercept, or we can really say our y-intercept is 0, okay? Because it doesn't cost us anything to buy 0 gallons of gasoline. This is also what we call direct variation. There's a direct relationship between the number of the item and the change or the cost of the item, okay? So if you have a y-intercept of 0, okay, then it's called direct variation. It's a direct relationship between our two items. So now let's actually write our equation. So instead of y equals mx plus b, we'll use c equals mg plus b. Okay, so c is our cost. So c is going to stay the same. M is that slope that we found, so 142. G is our number of gallons. And then we already talked about our b being 0. So if you notice with our direct variation, okay, we get just that. This variable is related to this variable by this number. Okay, it's directly related. There's nothing extra, no, extra stuff going on in the situation. Okay. So now let's look at some a little bit more normal to our standard linear equations. So Abby was on her last day of vacation. That was 320 miles away from home. She was trying to calculate how long it would take for her to get home the next day. She estimated that she would be driving at 60 miles per hour. What is the slope of this situation? So the key thing with word problems is really understanding the situation. So Abby is 320 miles away, and she wants to calculate how long it's going to take her to drive that full 320 miles. So we really want to say, we want an equation that's going to show us when she's going to get to 0, when she's going to be at her home. Okay, so I would say 320 miles, that sounds like her starting position, right? Her initial, okay? So we would say B, our y-intercept, our initial value would be 320 miles, okay? Then she is driving 60 miles per hour, okay? Now, driving 60 miles per hour, that would seem like a positive amount, right? Because she's driving a positive speed of 60 miles per hour. But remember, I want to take away miles because I want to get down to 0 miles. I want to see how long it takes her to get to exactly 0 miles away from her home. So I'm actually going to say my slope, okay, in miles per hour. So we see that per word. That's what MPH means. So that's why we know this is our slope, okay? So our slope would be equal to negative 60 miles per hour because she's getting closer. She's subtracting away 60 miles every hour from her distance. So I have slope, I have my y-intercept, so I just plug both into my equation. So y is equal to negative 60x plus 320. So the hardest thing with word problems is understanding what's the y-intercept and what's the slope, and then understanding the value of each, if it's going to be a positive value or if it's a negative value. So, it's just reading the situation and understanding what's going on. Okay. Let's look at another one. Number 10. So researchers in Antarctica discovered a warm sea current under a glacier that is causing the glacier to melt. The ice shelf of the glacier had a thickness of approximately 450 meters when it was first discovered. The thickness of the ice shelf is decreasing at an average rate of 0.06 meters per day. What is the rate of change of the situation? Okay, and we're going to write the whole equation. So even though it says rate of change and the last one said slope, we're going to write the whole equation. Okay, so the ice shelf of the glacier has a thickness of approximately 450 meters. Okay, so that's its starting thickness, right? That's its starting value. So B is equal to 450, as I can't write a 5, meters. Okay, then anything that we see rate of change, so a per and each and every, we see decreasing at an average rate of 0.06 meters per day. So that's definitely our slope. And it's decreasing, so I would say it makes most sense to make it negative 0.06 meters per day. Okay, so now we just need to plug both of these into our equation. So y is equal to negative 0.06 x plus 450. All right, and that is all it takes to write linear equations. We're going to be practicing these over the next couple of days. So obviously ask your teachers lots of questions, but that is writing linear equations kind of in a nutshell.